Alright, so let's talk about square roots. So first we're going to start with a square. So you can draw a square here. So we have a square that's 3 units by 3 units. So the area of that square is 9. So we could just write that as 3 squared. So if we had another square that's 2 by 2, there, that square would be 4, and we could write that as 2 squared. Do one more. So if we had a 4 by 4 square, that area would be 16, or we could write that as 16 squared. So that's squares, and hopefully you already knew that part of it. And so the opposite of a square is a square root. And that's a key thing to know. The opposite of a square is in another shape. The opposite of a square is a square root. So if I was to square root 3 squared, I would get an answer of 3. If I was to square root 2 squared, I'd get an answer of 2. If I square root 16 squared, I'd get an answer of 16. So what if I don't have those squares in there? So what if I just had square root of 9, square root of 4, and square root of 16? So again, you're just 3 squared is 9, so the square root of 9 would just be 3. The square root of 4 would be 2, and the square root of 16 would be 4. So when you're doing square roots, it's just the opposite of a square. Instead of the number times itself, it's the number divided by the same number. So in the case of 16, square root of 16, 4 times 4 is 16. In the case of square root of 4, 2 times 2 is 4. And square root of 9, 3 times 3 is 9. So it's the number times itself, but you're just thinking backwards from a square. So let's do a couple where they don't work out quite so nicely. So if we had a number like square root of 20, well, there's no number times itself that equals 20. There are numbers around it that you can do a perfect square root. So we know square root of 16 and square root of 25. So 16 would be 4 times 4, so the square root of 16 would be 4, and 25 is 5 times 5, so the square root of 25 would be 5. So we know that the square root of 20 is somewhere in between 20 and 5. And there's two ways to get close to your answer. One is just to look at 16 and 25 and determine which one 20 is closer to. So it's 4 away from 16 and it's 5 away from 20. So you could estimate it to be about 4. You could also estimate it to be, it's almost halfway, so a little less than 5. So it could be 4.4 would be a good estimate as well. If you were to use a calculator and get an estimate that way, you would type it in as square root of 20, and you would get a number of, and again this is an estimation, so it would be about 4.472135 9, and goes on forever. And you'll notice that this number just keeps going and it doesn't really make a lot of sense. It doesn't repeat and it doesn't end. So this is what we call an irrational number. So any square root that isn't perfect, like the square root of 16 and the square root of 25, is going to be called an irrational number. and I will continue this in the next video.